This video, what I want to show you is how you can easily increase your marks by 30%. Obviously, we are going section by section. In this section, we're going to be talking about Newton's laws. So, Newton's laws, you get them in question 2 of your exam paper as seen here. Now, if you can see the two questions that I have shown you in these two pictures, this is pure recall. So these are things that you can study and be able to give answers for in your exam. So now let's look at this one. 2.1.1 says state Newton's third law. When object A exerts a force on object B simultaneously exerts an opposite directly force of equal magnitude on object A. This is a Newton's definition. If you give this answer, you have easily secured yourself 2 marks, right? Now, let's do the most challenging part of the question, but it is still a recall question. Okay, so question 2.1.2. Just want to get my cursor here, get my mouse back in there. Let's see. This thing is not on. Sorry about this, guys. Oh, there it is right there. Okay. Okay, we are back in business. Now, we are going to calculate the tension in the string. So 2 blocks of mass m kg and 2.5 kg respectively are connected by a light inextendable string. The string runs over a light frictionless pulley as shown in the diagram below. So now we need to calculate the tension in the spring. Okay. So what we're going to do, we're going to go here. Now, we know that since the system is stationary, we know that F net is equal to 0. Okay? Now, if you were to draw a free body diagram, the 2.5 kg block is hanging, right? Okay, so now we first need to calculate the gravitational force. So F gravitational is equal to mass times G, which will give us 2.5 kgs multiplied by 9,8, right? Which will give us, if you type that into a calculator, it will give us 24.5 newtons. Okay, now F net is 0, right? So F net equals 0. F net is a combination of the tension minus the weight, which is equal to 0. And the tension is equal to the weight, which then makes the tension in the string 24.5 newtons. Okay, let's answer the second part of the question. Now, remember, in this video, what you need to remember is answering recall questions will pick you up 30%. Okay, state Newton's second law of motion in words. So this means that you need to write out the definition in words. When a net force acts on an object, the object will accelerate in the direction of the force at an accelerated direction proportion to the force and inversely proportion to the mass of the object. Now, we know that F net is equal to mass times acceleration. If you write down this definition exactly the way it is, you should get your 2 marks. Okay, draw a labeled free body diagram or indicating all forces acting on the 5 kg block. Now, what is important to understand here is that we have isolated the 5 kg block. Now, a free body diagram, what you do, you're going to draw a dot there. Right? That is the 5 kg block. There's a force here and there is a force here. You're going to call this force T1, right? Then you're going to call this force T2. Okay? Now, what you do now is say T1 is equals to tension. Then T2 is equals to tension. But remember, there is also weight here. So you need to say, call that weight or the gravitational force. If you have done this in this way, you should get your 3 marks. The reason why we said that there is tension, it's because 2 blocks of a mass 20 kg and 5 kg respectively are connected by a light inextendable string. P, a second light inextendable spring, and Q is attached to the 5 kg block which runs over a light frictionless pulley. A constant horizontal force of 250 newtons pulls the second string as shown in the diagram below. The magnitudes of the tension P and Q are T1 and T2 respectively. At this present moment, because we are not told what happens, we assume that all the forces acting are frictionless, right, and they are stationary.